Welcome to the ACS Technical Advisory Board podcast series, where we talk all things tech including data, cyber, AI, blockchain, and Internet of Things. Meet your host, Dr. David Cook, Vice President of the Australian Computer Society's Technical Boards. David is a technology advocate dedicated to advances and progression of computing and human-computer interaction. In today's episode, David talks with Tom Zord. Tom is the chair of the ACS Internet of Things Committee and a representative of Standards Australia. Tom is an independent management consultant who specializes in helping organizations to define and govern their digital strategy. Join us as we talk about the big-ticket concerns with IoT and how businesses can leverage the often overlooked value in adopting IoT practices.
Tom Zord is known for his vision and leadership. He's brought volunteers and industry together to build a large-scale wireless network for Internet of Things solutions and talent. Tom is the chair of the ACS IoT Internet of Things Committee and is part of the Technical Advisory Board for the ACS. And he's a representative for Standards Australia. Tom is an independent management consultant helping organisations to define and govern their digital strategy. Tom, welcome to the program.
Thank you, David.
Let's start by an easy question. What excites you about the Internet of Things?
To me, the Internet of Things is about better decision making. So I think decisions are so important in everything we do and everything we've done in the past, and some of the problems we have in the past is because of poor decisions. And Internet of Things really is about sensing data to detect events and allowing us to forecast events more than what we've been doing in the past, which has mainly been the weather. But now we can introduce decision making and forecasting into all sorts of situations. So farming and industry, supply chains, logistics, all those sorts of things can now be forecasted, and you can intercept events before they happen and create better outcomes. So that's really, really exciting.
A lot of promises were made from IoT's entry from 10 years ago, I suppose. From your experience, what are the challenges that are emerging now?
A lot of promises were made, and there has been a lot of challenge in implementing IoT. Firstly, we've got to recognise that government and industry have a lot of invested infrastructure or investment in infrastructure, which is legacy infrastructure, and it's got many years of good life still in it. And presenting a business case to replace that with a smart enabled or Internet Things enabled capability isn't always viable. You need to see things out to the end of life. So there's opportunity then to introduce Internet of Things as an add-on, but that has been a big challenge. Another big challenge has been skills, sourcing the right skills, and also applying consistent standards across the implementation of IoT. Part of the challenge as well with industry is that facilities that could have applied IoT is often operated and owned by different parties. And those two parties have different goals. And so even proposing a business case around the value of IoT is very difficult because there's these two different parties, the owner and the operator. And one of the technical challenges for the implementation of IoT is securing IoT in day-to-day operation. So the Internet of Things has many technical layers, and each of these layers are often managed or by a set of services from multiple vendors. So you can think the devices themselves, the deployment, the facilities it's in, the communication networks, the cloud provider, the applications that are written on top of that, often various service providers. And so to get a secure environment, you need to have really good understanding of where did the data come from? Can you trust that? How was it handled along the way? And is it being applied and used in context and appropriate situation for what it was collected for? So often you mix an IoT solution with data you collect yourself, as well as data you source from elsewhere, but that data you source from elsewhere may not be for that context. So the timestamps and the context that was provided in needs to match up. So it's very important that it's responsible use or use by design. And the security around that is making sure that there's some control and governance around what it was designed for, how it will be used.
I see a lot of the implementation in agtech where, and I'm really interested that you brought up the issue of legacy systems and the importance of end of life. But I see bolt-on solutions popping up in the ag sector all the time, where people are saying, well, I've got this water management system and that's been working fine, so I'll just keep that. But I'll bolt something else here on the side of a water tank or try and include that into the data aggregate. And by the way, I'm using the Department of Agricultural satellite details from 10 years ago, and I'm overlaying that into the predictive model and all of those sorts of things. What's your thinking there? Is it really better to just completely start afresh? Should we be pushing that a little bit more than we currently do, or are you okay for the compromise solutions that are emerging?
To get people in the mindset, a bolt-on solution is perfect. Do a proof of concept, and these have been the approaches for smart city and smart farming. Try something out, proof of concept, do a bolt-on solution, get some data, prove that it's viable, and it's also a cheap way into the process. The downfalls with that is that it doesn't set you up to be able to share that data efficiently across industry. So if you think government and industry sharing data in a consistent, interoperable way, these bolt-on solutions are not necessarily built to a common interoperability standard. And also, they're also built from a tactical perspective rather than a broader industry use case where various industry partners work around a collaboration framework or architecture so that their different solutions can work together. And that's where the real opportunity for IoT is.
So in terms of IoT devices, we see devices that are typically low bandwidth, low power, low code. So what are the evolving risks, I suppose, cyber risks of IoTs? Is there a concern there?
That's absolutely a concern. Cyber risk for IoT is very, very real in the fact that IoT is rooted in the physical world. So it's beyond just brand reputation and data loss. It can affect, especially in a case of critical infrastructure, we really need to look at risk through the lens of unintended consequences and who's impacted at the end of the day. And traditional methods of monitoring and redundancy, as well as a human in the loop, is absolutely important for critical infrastructure.
With all of these different challenges, I guess, in terms of cyber, physical, the risk and so on, what do you think will drive large-scale IoT adoption?
I think we need a high-demand innovation that is as big as the light bulb. So the light bulb was invented and it drove electrification and installation of that infrastructure. So to get a IoT infrastructure, and that might look like an IoT platform, but certainly a set of consistent standards. The way on the electrical grid, we have a consistent standard around voltage and standards around how it's wired up. If to get that implemented for IoT, we need a big in-demand or killer app kind of innovation.
So, I mean, there's lots of options. I don't know, robotics, other things. What would be that high demand innovation look like?
I don't know, but I would, from my experience, I think some of the things like autonomous robotics that we're seeing now, specifically currently we're seeing them in mining, autonomous robots doing repetitive and dangerous work. We also see it in exploration in subsurface and more in space as well. So for autonomous maintenance bots to make their way through, they need to be able to communicate with their environment around them. And we need some infrastructure like for beacons, for location, and obviously communication networks to be in place. Some people already have Roomba robots around their house. So we do have autonomous bots. More maintenance services, I believe, will be a candidate as a catalyst to drive large-scale adoption.
Tom Zoord, thank you for your time today.
Thank you.
To find out more about how the ACS is powering Australia's technology brilliance, visit us at our website, Facebook or LinkedIn. Want to get involved with the ACS technical boards? Email us at tab@acs.org.au and tell us a bit about yourself. Join us for more thought leadership, ideas, and information through our other podcasts on the ACS YouTube, Facebook, or on LinkedIn.